Alrighty, in this video we are going to be talking about the calculus of polar equations and all of that good stuff with it. To find a tangent line to a polar curve described by r is equal to f of theta, we are going to be considering theta as a parameter and write the parametric equation that describes the curve x is equal to r cosine of theta, and that's going to be equal to f of theta cosine of theta, and of course for sine r sine of theta, that's going to be f of theta sine of theta. Now, to find the derivative of dy dx, what we're going to be using is the chain rule of this right here. So to find dy dx here, I'm going to have dy d theta over dx d theta. In order to do that, I'm going to use chain for this right here. I'm going to use chain for this right here. So for the first part, whenever I want to find dy d theta, I'm going to do first times the derivative of the second plus second times the derivative of the first. So you're going to get r cosine of theta plus r prime cosine of theta. And then to find dx d theta, we are going to do the same thing. So first times the derivative of the second, you're going to get negative r sine of theta plus second times the derivative of the first. So that gives you this right here. Now, a couple of remarks. If we have a horizontal tangent line, then that's going to be dy d theta, which means that we're just going to set the numerator equal to 0, given that dx d theta is not 0. Likewise, we have a vertical tangent line when dx d theta is equal to 0, provided that your numerator is not 0. Okay, so let's consider the cardioid described by the polar equation r is equal to 1 plus sine of theta. We want to find the slope of the tangent line of the cardioid when theta is equal to pi over 3. Okay, so essentially we're going to be using this right here. So dy dx at theta is equal to pi over 3 will be r of pi over 3 cosine pi over 3 plus r prime pi over 3 sine pi over 3 all over negative r of pi over 3 sine pi over 3 plus r prime pi over 3 cosine pi over 3. Now, on the AP exam, they kind of do want you guys to show out the intermediate steps, aka what did you plug in? In this case, I plugged in this to get this right here. And then this will not be a valid answer because these aren't really numbers. So you are going to have to evaluate all of this for your final answer. And then substitute everything back in. So here we are going to find out what r is. We're going to find out what r prime is. We're going to find out what cosine of pi over 3 is. And then we're going to figure out what sine pi over 3 is. And then we are just going to substitute in and call it a day. So with r pi over 3, I'm just going to plug in pi over 3 here. So 1 plus sine pi over 3, if I'm thinking about pi over 3 and sine, that is going to be root 3 over 2. Now for r prime of pi over 3, I need to find my derivative of this right here. That's just going to be cosine. So that right there is going to be cosine of pi over 3. That is going to be 1/2. Well, then this is going to be 1/2. And then sine pi over 3 is just going to be root 3 over 2. I'm going to use different colors just so that you guys can see what's happening here. If I can. We'll see. Okay, so we have that. We have that. Let's use red. This one. I guess we could do pink. Then this one. We could do green. This one will be back to blue. Okay, so we're going to sub in everything we know in terms of dy dx. We know that r pi over 3 is going to be 1 plus root 3 over 2. So that's going to be in blue. Of course, let me condense this a little bit. Just so that I have space. Okay, so I have that cosine of pi over 3 we said was 1/2. R prime of pi over 3 we said was also 1/2, which is in red. Let me find that. And then we said that sine pi over 3 was 3 over 2. Close enough in terms of green, right? All over negative r of pi over 3. So this blue, but make it negative. Sine pi over 3, which is going to be 3 over 2. Plus r prime of pi over 3, so this we're at 1/2. And then times cosine of pi over 3, which is going to be 1/2. Now, using our handy-dandy calculator, what we're going to do, of course, is just plug all of this in and see what we get. And surprisingly, we get a fat -1 as our answer. I know, crazy. All right, part B says, find the points on the cardioid where the tangent line is horizontal. That means that we have dy d theta being 0. So I am going to just look at my numerator. Okay, so that is when we have r, in this case, 1 plus sine of theta, cosine of theta, plus r prime, and we said that was just cosine of theta. And then, of course, we have sine of theta. Now we're going to set that equal to 0. And in order to do that, we are going to do some manipulation. Notice we have a cosine here and a cosine here. So I'm going to factor out a cosine. What I'm left over is 1 plus sine on the first term, and then sine on the second term. And that's going to give me cosine of theta 1 plus 2 sine of theta is equal to 0. So now I have cosine of theta is equal to 0, and then sine of theta is equal to -1/2. We know that cosine of theta is equal to 0 whenever theta is pi over 2 and 3 pi over 2. And then we know that sine of theta is equal to -1/2 whenever we have 7 pi over 6 and 11 pi over 6. Now, part B and part C says we are going to find points. These points are going to be polar coordinates. So all we're going to do here is just plug in theta into my r value right here to get my distance. We are not going to do that until we complete C because something happens with B and C. And you'll probably notice it here on the graph in terms of what's about to happen. But we'll see in part C. Now, part C says find the points when the tangent line is vertical. So that is whenever we have dx d theta is equal to 0. So that means I'm going to look at my denominator. So I have -r. So that's going to be 1 plus sine of theta of sine of theta plus r prime, which we said was cosine of theta. And then we have cosine of theta. All right, so if I simplify that, I'm going to get negative sine plus sine square of theta plus cosine square of theta is equal to 0. I kind of have a dilemma right here. Right now, I have a cosine square of theta, and then I have a sine and a sine right here. So most likely what I'm going to have to do here... Oops, I forgot to make sure this is negative. What I forgot to do... Here's... distribute this negative. Most likely what I'm going to do here with this cosine square of theta is make it so that it looks like a sine, since we have a sine here and a sine here. So you're factoring identities that are going to come into play in this unit. We know that cosine square is going to be 1 minus sine square of theta. And then I'm going to simplify that a little bit. Negative 2 sine square of theta minus sine of theta plus 1 is equal to 0. I am, because I prefer my coefficient, my leading coefficient to be positive, I am going to change my sign so that I have a positive, and then a negative 1 right here. And then I'm going to factor this. So this is factors of negative 2. That's going to give me a positive 1. That's going to be 2 and 1. I am going to factor this. So I have 2x plus, well, let me do this. I have x plus 2, and then x plus 1. That's going to give me x plus 1, 2x plus 1, and then, of course, just substitute it in terms of sine. So now I have sine x plus 1 to x plus 1 is equal to 0. So now you have sine of x is equal to negative 1, and then, oops, and then this right here. When sine x is equal to negative a half. Well, we know that sine of x is equal to negative 1 whenever x, or theta, why did I say x? Theta is equal to 3 pi over 2. And then we also know that sine of theta is equal to negative a half whenever theta is pi over 6 and 5 pi over 6. Something's off. Let me find that. So that should be a negative 1, which means that this should have been a negative 1, which means this should have been a negative 1. That's a positive 1. Okay, there you go. So theta is equal to 5 pi over 6 and pi over 6. Now, the reason why I didn't find points for B and points for C just yet is because remember that the curve is horizontal and vertical whenever the other derivative is not 0. Here, you'll notice that we have 3 pi over 2 right here and 3 pi over 2 right here, which tells me that 3 pi over 2 is not differentiable. And you'll also notice that here we have a little cusp right here at 3 pi over 2. So that, hopefully you saw that in terms of us can't having 3 pi over 2. All right, now once you do that, of course, since B and C says find the points, we are just going to plug in our theta values and then find R. Lucky for us, hopefully you guys got some of these, especially in terms of, let's say, sine. So like here, because sine is negative a half, this tells me that I'm just going to plug in negative a half here. That's going to give me 1/2. So then I'm going to get 1/2 7 pi over 6 and 1/2 11 pi over 6 for that one. For pi over 2, we are going to have to plug in because we can't really do sine here. So for pi over 2, sine of pi over 2 is going to be 1. 1 plus 1 is 2. So that means my r value is 2, pi over 2. Lucky for us for sine, because my r value has a sine, we could just plug in my value of 1/2 here. Plugging in 1/2, 1 plus 1/2 is 3/2. So now I have my coordinates being 3/2, pi over 6, and 3/2, 5 pi over 6. Fun stuff. All right, let's go ahead and do 3. 3 says, find the equation of the tangent line to r is equal to 2 times 1 minus sine of theta at 2, 0. One thing that you want to note is that 2, 0 is your polar coordinate. So this is r comma theta, not xy. So this means that your theta is going to be 0. All right, now to find your derivative, remember that that's going to be dy dx is equal to r cosine of theta plus r prime sine of theta over negative r sine of theta plus r prime cosine of theta. If you can't remember that, just use the product rule and call it a day. All right, now what we're going to be doing is plugging in everything we know in terms of r prime, cosine, and sine at 0. So what I'm going to do is go ahead and make my little chart at r is equal to r of 0, r prime of 0, cosine of 0, then sine of 0, and then I'm going to plug everything in. Well, if r is 0, or if theta is 0, this tells me that my r value is going to be, of course, 2. Because if sine is 0, that's just going to be 0. 1 minus 0 is just 1. 1 times 2 is 2. We got to figure out what the derivative of that is. I'm going to simplify this. That's 2 minus 2 sine of theta, which means that r prime is negative 2 cosine of theta. And then if I'm plugging in cosine for 0, I'm going to get 1. So that means that r prime of 0 is going to give us negative 2. Okay, cosine of 0 is just going to give us 1. And then sine of 0 is going to give us 0. Okay, what we're going to do now is just plug and check everything we know. So we have 2. Cosine of 0 is 1. R prime of 0 is negative 2. Sine of theta is, sine of 0 is 0. All over r again, so 2, negative 2. Sine is 0. R prime of 0 is negative 2. And then cosine is 1. You'll notice that this right here and this right here is going to be 0. So now you're just left with 2 over negative 2, which is going to give us a slope of negative 1. Now, for number 3, because we are trying to find the equation of the tangent line, we want the tangent line to be in a rectangular equation, a rectangular coordinate. So what we need to do here is figure out what x and y is based off of what we know of r and theta. So remember that x is equal to r cosine of theta and y is equal to r sine of theta. If r is 2 and cosine is 0, I'm going to do 2 cosine of 0 and then 2 sine of 0. Well, 2 cosine of 0 is 2, and then 2 sine of 0 is 0. So my rectangular coordinate is 2, 0. Which kind of makes sense because if you were to plot this right here, that's going to be 2, 0 anyways. So then you're going to have y minus 0 is equal to negative 1, x minus 2 as your tangent line equation. All right. Let's go ahead and do something like 6, where we want to find the equation again. This time, they give you that r is 3 pi over 2, but we don't know what theta is. Remember that whenever we want to take the derivative, we essentially need theta. So here, if r is 3 pi over 2, and that's 3 theta, this is going to give me theta being pi over 2. So whenever we take the derivative, this is going to be in terms of pi over 2. So this right here is 3 pi over 2, pi over 2. We're going to need that, and remember that this is r comma theta. All right, so to find the derivative, I'm just going to copy and paste this right here, and then plug in everything I know in terms of theta being pi over 2. What is that? Well, let's find out. Of course, I'm going to have to erase that. This is pi over 2. Now, if I plug in pi over 2, r is going to be 3 pi over 2 just because they gave that to me. So that one wasn't that bad. R prime, though, we are going to take the derivative of this, and that's just going to be, plot twist, 3. So that's just going to give us 3. Cosine of pi over 2 is going to be 0, and then sine of pi over 2 is going to give us 1. I'm going to plug everything in now. So now I have 3 pi over 2. Cosine of pi over 2 is 0. So that is going to be 0. R prime of pi over 2 is 3. Sine of pi over 2 is 1. All over negative 3 pi over 2. Sine of pi over 2 is 1. R prime of pi over 2 is 3. And then, of course, cosine pi over 2 is 0. You'll notice that this right here and this right here will cancel out. So now you're left with 3 over negative 3 pi over 2. What we are going to do here is try to simplify this a little bit to make it prettier. That's going to be the same thing as 3 times negative 2 over 3 pi. Cancel out the 3's. So now you're just left with negative 2 over pi. And that's your slope. Now, once again, as a reminder, this right here is in polar coordinates, so r comma theta. We're going to need to find out what x and y is, my Cartesian points, for number 6. So what I'm going to do is go ahead and say x is equal to r cosine of theta, y is equal to r sine of theta. X right here is, well, x, honestly, I don't really care about because cosine of pi over 2 is going to be 0 anyways. So that means that x is going to be 0. Now, y, though, your r is going to be 3 pi over 2. And then sine of pi over 2 is just going to be 1. So your coordinate is 0, 3 pi over 2. And then, of course, put everything together. You are going to get y minus 3 pi over 2 is equal to negative 2 over pi, x minus 0. And that right there is your equation of the tangent line. course, let's go ahead and visualize this. So what I'm going to do is put this on Desmos. So here, r is equal to 3 theta. And we want the point, the rectangular point of 0, 3 pi over 2. So 0, comma, 3 pi over 2. It's that thing right there. What we're going to do, of course, is now plot the tangent line. It's equal to negative 2 over pi, and then x. And that right there gives us my tangent line of this polar graph right here. Pretty cute, I would say. All right, in the next video, we are going to be talking about more on polar equations in terms of parametrics. So we're going to be doing a lot more of PVA and, of course, chain rule in the next video.